In this lesson, we'll be solving a practice problem. This is a real-life application of the sequence and series. And in this lesson, we are using percentages as we have introduced them in the last video or the last lesson. So, there are 50 liters of water in a container. Water evaporates from this container at a rate of 1% per hour under certain weather conditions. How much water will be left in the container after 8 hours if left under these conditions? Okay, so someone works here. We have a container initially at T0. We have a container which has 50 liters. So it's going to decrease. Okay, when water evaporates, it means it is decreasing, and we are dealing with percentage decrease. That's the first thing that you must note there. So what is percentage decrease? Okay, so to get the new amount, we are looking for the new amount at T1 after the first hour. We're going to do what we have done in the last example, that the new amount is equal to, you can work that separate and then you plug it on T1. So let's erase here. So here we're going to have T1, and we're going to say that the new amount is equal to the initial amount multiplied by 100% minus a percentage decrease. So initial amount is equal to 50 multiplied by 100% minus 1%, and that is 50 multiplied by 99%. So you are going to have 50 multiplied by 99%, and that is T1. So after the first hour, we are going to have 50 multiplied by 99%. So we're going to erase here and do the second one. After the second hour is T2. We're going to say plus. So what we're going to do here is that we're going to say that the initial amount in this case is now this one. Okay, I hope you understand what I'm trying to say here. The new amount is now this one. We want to know after the second hour how much will be left, assuming that the initial amount was the term that is before. So we're going to say that the new amount is equal to the initial amount multiplied by 100% minus the percentage decrease. So initial amount is given as 50 multiplied by 99%, and that's going to be multiplied by 100% minus 1%. So notice what we get here. We're going to have 50 multiplied by 99% multiplied by 99%, and at the end we're going to have 50 multiplied by 99% squared, and that's term number 2. So it means that here we're going to have 50 multiplied by 99% squared, and they're going to add each other up until the term number 8. Okay, so let's erase here. So that is our series here. The series of evaporations is this one. That is the series of evaporations. Okay, so after the first hour we have lost this amount. After the second hour we have lost this amount. That amount until we reach the 80th hour. We don't count this one. This is what was there initially. Nothing was lost. Initially we had 50, so just ignore it. We want to know how much will be in the container after 8 hours. So this is a geometric series, if we can check. How can we prove it? We can say that R is equal to T2 over T1 is equal to T3 over T2. Or you can check that to move from T1 T1 to T2, we multiplied by the ratio, which is 99%. Isn't it that 50 multiplied by 99% times 99% will give you 50 times 99% squared? So, to move from T number 1, to move from this one to this one, we multiplied by 99%. So it means that our ratio in this case is equal to 99%. And what is the value of A? The value of A is T1. T1, which is 50 times 99%. So A is equal to 50 multiplied by 99%. And we are going to calculate T8. That is what will be left after the 80th hour. The 8th hour. So, because it's an arithmetic, we're going to say that Tn is equal to AR to the power of n minus 1. Because we want T8, we're going to use the formula for Tn. Okay, so we're going to say that the first term is equal to 50 multiplied by 99%. That's the first term. Multiplied by 99% to the power of 8 minus 1. And we are going to punch all that on the calculator. That is T8. T8 means the amount that will be left after the 8th hour. So 50 multiplied by 99% times 99% to the power of 8 minus 1. And that gives us 46,14. And the answer there will be 46,14. Okay, so this is the amount which will be lost after, that will be remaining in the container after 8 hours. So here on T1, if we say 50 times 99%, I want us to understand each other clearly here. No one should be left on suspense. Okay, so at T0 we had 50. Let's see T1. We're going to say 50 times 99%. I want us to expand that. What do we get? We get 49.5. So here we have 49.5. And then plus. Let's see what we will have after the second hour. How much will be left? It's 50 times 99% squared. And that is 49.01. That is 49.01. Okay, so we can see that at T0 it was 50, at T1 is 49.5, at T2 is 49.01. So we want to know how much will be there at T8 after the hour 8 or the 8th hour. So at the second hour we have 49.01. After the first hour we have 49.5. It's no longer 50. I hope you understand this. So make sure you're able to use percentages. That's why I have decided to record the lesson of percentage increase and decrease before I went to the actual one. So you must know that percentage increase is equal to the new amount is equal to the initial amount multiplied by 1 comma the increase. And then for a percentage decrease, the new amount is equal to the initial amount multiplied by 100% minus or subtract the percentage decrease. And this is how we can solve it. If you don't understand, feel free to ask in the comment section and I will come to you. Thank you.